So welcome to CS 253. The vast majority of you here are undergrads taking the classes 3, 253. There's maybe a handful of grad students taking the classes 5, 253. That doesn't matter for most of our discussions, but when the assignments come out and the quizzes come out, it'll make a tiny bit of difference. So I'll talk more about that in a second. First and foremost, it's really great to see everybody, literally see everybody, not just faces on a screen, so that's awesome. And we're going to try to do our classes in person this semester. Keep your fingers crossed, knock on wood, throw salt over your shoulders, hoping that it continues that way. If for some reason things go awry, it's easy enough to move back to online versions, and there may be a time or two where we have to do that for other reasons, but let's keep our fingers crossed that we're mostly in person. So what I'm going to do to start out with is give an overview of what the course is about, and then we'll start talking about the course material, and I'll give you some tips on where to find all the other information you'll need for the class here very shortly. So we're going to start out in the first part of this lesson talking about kind of what the philosophy is of the course. We'll then talk about the contents of the course. We'll talk about how the lecture material will be structured, and I'll give you an overview of the assignments and the assessment method. So if you've no doubt noticed, there's lots and lots of cores available now. Most computers, including smartphones like this one, have 4 cores. And or that's becoming very common. My laptop has 8 hyper-threaded cores, so it's got 16 virtual cores, lots of cores. They'll talk about why that is in a second. And so one of the consequences are that there's people, companies and agencies and sponsors and so on, customers, who need to have people who know how to take advantage of all those cores. And we'll talk a bit more about why that's important as we get along here as well. The main reason is that applications have increasingly large need for processing, and you can't necessarily do all the processing you want to do with just a single core. If you could even buy a single core computer these days, because it's very hard to buy one like that. The reason why we have so many cores is largely driven by advances in hardware and software. So there's something called Moore's Law, which said that every 18 to 24 months, the number of transistors on a chip would double. That's what Moore's Law says. I keep trying to point to the screen. That's not going to get us very far, is it? But the basic point here is that with Moore's Law, the numbers of transistors on a chip has increased, but the ability of being able to get the clock speeds to run faster and faster kind of petered out around the early 2000 timeframe. And so as a consequence, what we're doing with all those extra cores these days all those extra transistors is making multi-core processors. So that's what those cores are being used for now. There's also been lots of other advances in software at the operating system level, things like multi-threaded operating systems. Everything's multi-threaded now. That wasn't the case 20, 30 years ago. And perhaps even more importantly for this course, there's also great support in various layers above the operating system. So the virtual machine layers, the layers of middleware, and we'll spend a lot of time talking about that because that's really, really cool. So the point is that there's an abundancy of cores, and so being able to take advantage of those cores is important to be able to keep up with demands on the application processing. So how do you learn to take advantage of this stuff? Well, one way to do it would be to spend a lot of time reading papers and theoretical theses and so on, treatises on the concept of concurrency and parallelism and so on. And we could talk a lot about the concepts, and we will talk a lot about concepts, but we need to do more than just talk about concepts. It's really important to do more than just sit and think. So what we want to be able to do is be able to see by example how we can make these systems work, how we can make them easier to write, easier to read by using various techniques we'll talk about and patterns, easier to maintain and modify, we'll talk about techniques and patterns, and also more efficient and resilient. There's no point in having all this hardware out there and all this low-level operating system and infrastructure software that takes advantage of multiple cores, and then we not know how to use that in our programs. And when we talk about the different paradigms of programming, concurrency and parallelism here shortly, you'll get a good feeling for how this has evolved over time to make things much easier. In fact, there's some very recent advances, so recent that they're still in early access mode, that gives you a lot of ability to be able to use pretty straightforward concurrency programming models and get great speed ups. And so we'll talk about that as well. The way we're going to do this is we're going to apply patterns. Hopefully you got a chance to learn a bit about patterns in some earlier courses like CS 3251 or the equivalent if you went somewhere else, as well as object-oriented and functional programming techniques. So we're going to do a lot of hands-on design and coding and some testing as well, which will be fun. So what will the course cover? There are really going to be a couple of main things we're going to focus on. First, we're going to talk about a bunch of Java concurrency and parallelism frameworks, where the focus really is on parallel processing. I teach a sister course to this one, or a sibling course to this one, which will occur in the spring, where we talk about object-oriented concurrent programming. And this course is going to be a lot more on functional parallel programming. So it's more, and I'll just explain what the differences are here shortly. So the three main Java things we're going to look at in this space will be streams and parallel streams, with the emphasis on parallel streams, but we need to know about streams first, and that'll actually be what your first assignment will cover. We'll also talk a bit about completable futures, which is this interesting asynchronous programming model, and then we'll talk about something called reactive streams, which is even more modern than the other two approaches in many ways, and kind of combines the best of both the streams, parallel streams paradigm and the completable futures paradigm. So those are some things we'll talk about. This assumes knowledge of object-oriented Java and functional Java, and I'll give you some tips on where to learn more about that if you need a refresher on some of that. The other thing we're going to talk about, which is really exciting because I haven't done this in this class before. I started doing this over the summer with another course I was teaching, and it turned out to be so cool I want to integrate it in with this material. It's basically how to build modern web applications. So modern web applications don't look a lot like the older legacy web applications. They're much cooler, and they take advantage of some of the things we just talked about here, like reactive streams, in order to be able to program entirely asynchronous web applications, which is really cool. And so you'll get a chance to learn how to program asynchronous client code, say on an Android device, or perhaps a web page using JavaScript or whatnot, and then move that back into the various levels of microservice-based servers, where each piece of this, including sort of an app gateway, middle tier style front-end server, will be asynchronous, and it will take requests that come in from clients asynchronously and distribute them to back-end microservices that will run asynchronously and will access information in databases asynchronously. So the whole thing becomes one gigantic asynchronous engine that does a fantastic job of really maximizing performance, which is the whole point of asynchrony. As you start to learn about asynchrony, you'll see that maximizing performance is very important. Now, we'll also touch base a little bit about some of these newer models that are coming along, where they're moving away from an entirely asynchronous approach to this cool thing called structured concurrency, which has become all the rage in languages like Kotlin. Java is getting there, and I'll talk about that, but we're not quite there yet for production use, so we won't spend a lot of time doing assignments with that, but I will talk about it, and maybe in the future we'll do something with that. We'll also be talking about patterns for parallel programming, patterns that are going to help make your designs more effective, and this is one of the passions I have about software development, is how to think about things from a design point of view, not just slinging code, which is important, but also about design. So we'll talk about some of those issues as well. I assume that you can, I assume that you know or can quickly learn enough of what you'll need in order to be able to do modern Java, and we'll talk more about that in a second. Android, you actually don't have to know a lot of Android. You have to know how to use Android Studio to do your compiling and running your tests. And Git, which is the source code repository we'll use, which is very popular. So, for the modern Java stuff, I'm assuming everybody here has the equivalent of CS 1101, which is object-oriented programming in Java. So I'm taking that as an assumption. However, if you need a refresher, if you go to this link, which will be in the slides, I will put the slides out for you as well, so you don't have to write this down. The slides will all be available, and you can click on the link and it'll take you to the web page and so on. That has the information about how you can enroll in a free Coursera course that I taught together with some people you probably know, like Jerry Roth and Julie Johnson, several years ago, where you can refresh your object-oriented Java chops. But I'm suspecting you won't have much problem with that. And moreover, we're mostly going to be focusing on functional programming. And there's a little playlist I put together. I think I sent it out in one of my welcome emails last week. That's on my YouTube playlist that goes over functional programming in Java. So if you're new to that, take a look at those videos. It's probably like an hour and a half worth of stuff. Hopefully pretty intuitive. All the source code, as always, is available in my GitHub repository. So take a look at those things if you need a refresher. So what will the lecture material cover? We're going to cover Java parallelism, which will involve Java sequential streams and parallel streams. We're going to start probably Monday with the Java stream stuff. Today I think we'll cover the background material on concurrency and parallelism. We'll talk about completable futures, which is this really cool asynchronous programming model, and then we'll talk about reactive streams. There's a couple of different variants of reactive streams. There's the so-called RxJava variant, and then there's the Project Reactor variant. We will be focusing here, when we get to that point, on Project Reactor, which is really cool because it comes integrated with something called Spring, which is an environment, a platform for doing modern web application development. And then we'll also talk about basically communication from mobile devices to servers using microservices, using Spring Web MVC and Spring Web Flux, and you'll get a little chance to play with both of those. This isn't really a course in web programming per se. We have other courses here that are taught, I believe, by Professor Hemingway that will give you a lot more experience with doing things like programming HTML5 and JavaScript in browsers. We're going to do just enough so you get to see how you can do modern, cool processing with parallel computing and concurrent programming in Java on both the client and the server side. And then, of course, we'll talk about patterns as well. So we'll have these different sections. We'll have lessons. The lessons have parts. Each part is a single lecture. Why am I telling you this? Because I'm going to be taking each of these individual lectures and uploading them to YouTube and then linking them together with the slides on my web page, which, again, I would be pointing to. But when you get the slides, you'll see there's a link you can go to, and all the lectures will be there. So it's a good place to go if you want to kind of see how what we've covered in the class. So if you can't make it, if you get sick, this is very important this year. Last night I did the the night before the first day of class thing over at the Commons, talking to a lot of engineering students who are about to start today with their new adventure at Vanderbilt. And a big question was, what happens if we get sick, which is a possibility. Let's hope it doesn't happen to us, but it could happen. And in this class, everything is recorded. Everything will be online. The quizzes will be online. We'll talk about that in a second. So even if you're not able to make it to class because you're sick, you can still keep up. As you'll see, I really want you to come to class, but we have provisions in case you can't, which is nice. Okay, so there will be bi-weekly quizzes on material that are covered in the lectures, and the first quiz will be next Wednesday. It will be a fairly straightforward quiz. It'll also be in Brightspace, and what I typically do is I say, here's a 12-hour period in which you can take the quiz, which is usually about a half hour long. So it gives you plenty of time to schedule things around your schedule, so you don't have to worry about cramming before you come to class. All the quizzes are intended to be closed book, closed note, closed internet, open mind, but closed everything else. And so I'll remind you about that, but that's obviously under the Vanderbilt Honor Code. We should be able to get the quizzes handed back by the beginning of the next class. So if it goes out on Wednesday, we should get the results back by the following Monday. And then what I typically do in class is I will go over the quiz and answer questions and so on. We're very fortunate to have some graders who've taken this class before, so that'll help us out. And they also have office hours. And if you go to the links on my webpage, which I'll show you shortly, you can see where when the office hours will be. I think most of them are going to be Zoom office hours. I'm still kind of wrestling with this. So I will be here in the morning on Monday and Wednesday before class, obviously. I still may want to do Zoom. It may be somewhat weird, like you could be sitting there and we'll Zoom, just because I prefer not to sit next to someone. It's not meant as an insult. I just think we're all better off. But we can actually talk to each other, just Zoom, to share screens. Actually, that's one of the things that turned out to be pretty good from the pandemic, was the ability to communicate in office hours by sharing a screen. I thought that was actually almost better than sitting next to someone in a lot of ways. How do you study for quizzes? Very common question. And in fact, I think that's in the frequently asked questions page on my website. So the best way to study for quizzes is to look at the slides. So all the slides will be available. A lot of the stuff comes right out of the slides, as well as watching the screencast, which will also be uploaded. And most importantly, once we get into the rhythm of the class, we'll be looking at the frequently made mistakes videos. And I'll talk a bit more about that when we talk about how the assessments are done. But the way that things will work, there'll be a video after I review everybody's assignments saying what people were doing that could be done better. And so the quizzes often a lot of the questions come from those things for various reasons. There may or may not be a cumulative final that covers all the lectures. If we have one, and I'll explain why we might not have one, then we'll focus really on the last weeks or so from the last quiz, so you won't have to study absolutely everything from day one. The reason we sometimes don't have the final is sometimes the final project tends to run a little long, and so I don't want people to stress out. So sometimes we trade off the final project for a final exam. So kind of depends how it goes. If there is a final exam, it'll be Saturday, December 18th at 7 p.m. Yet another reason why we might not want a final exam. I don't know about you, but that didn't seem like a lot of fun. And we would do it by Brightspace. And that's when it's officially in the books. What I would probably do is, again, if we have one, give you a 12-hour period to do the exam. But I don't know who came up with this schedule, but it seemed a little crazy. Okay, so let's talk about the assignments and the assessments. So the assignments should be written in, should actually say modern Java, not Java 8, because we're finally able to use Java 11 on Android. It's really exciting. Actually, it doesn't make that much difference, but it's still exciting. You can use any IDE you want to develop your code, but it has to run and the tests have to pass using Android Studio, the latest version of Android Studio, and Android 11, which is API 30. And I'll talk more about that in a second, where to get it. Java now comes pre-installed with Android. It comes pre-installed with the version of Android we're going to be using, which will be Java 11. So you don't have to worry about installing it. There's links that explain this stuff on my GitHub repository, which we'll walk through in a minute. So you have to submit things using Android Studio. Android Studio is pretty cool. It's basically a kind of a plug-in on top of IntelliJ. So if you've ever done any Java programming, you may have used IntelliJ. And we will actually use IntelliJ here in this course as well, because the server stuff that we do for web programming actually has to be done in IntelliJ, because it's not an Android project. It's a server project. But IntelliJ and Android Studio are very, very similar. Please install API 11, or Android 11 API version 30. I'll talk more about that. Does anybody who can see the screen know what the symbolism is of 11 on this? So this is from a classic movie called This Is Spinal Tap. And there's this recurring joke in there about the guy he's a musician and he wants his amp to go up to 11 because it's one louder than 10. So if you're a musician, you'll see why that's funny. If you're not a musician and you've never seen Spinal Tap, you're probably like, what the heck is he talking about? But it's worth understanding the meme, because it turns out to be a lot of stuff you'll see in pop culture references turning it to 11. So that's where they came up with that icon for Android. All the source code for the assignments and the examples are available in my GitHub account. This is a little bit, sometimes a little bit confusing, because you're going to be using GitLab accounts, and I'll explain why in a second, but my stuff is in GitHub. Turns out to be not that hard to deal with. So if you go to the GitHub account, you can clone the code, and I'll have some instructions on how to do that, and you'll find the assignments there. Assignment 1A is there, but I need to do a few more tweaks. I will be putting out a video here, hopefully in the next, probably by tomorrow morning if all goes well, that will walk through everything. So you're welcome to look at it now, but the code's likely to change a tiny bit, and you might want to wait for the video. But the good news is that'll explain how it all works and show you how to run the tests and so on. You'll need to use GitLab, and the main reason for using GitLab is that GitLab makes the repos private by default, whereas GitHub makes the repos public by default. And there's also some limitations that GitHub has that GitLab doesn't in this respect. So obviously for honor code reasons, we don't want all your code available for anybody to look at. So you'll need to learn to use GitLab if you don't know how to use it. I have a bunch of material in my FAQ and on my wiki page, which I'll show you, that will illustrate how to use this. There may be occasions when you'll need to update your repository. For example, the current version of assignment 1 that's sitting in my repo needs to be tweaked a little bit. And so I will make the changes, I'll push them to my repository, and then you'll need to update yours if you clone it. You might just want to wait until I send a message to Piazza saying everything's ready to go. But you may have to get in the practice of being able to update my stuff. And there's nice instructions on my website explaining how to do that, and I'll also talk about it in a video that will explain it as well. The assignments you'll do will provide a range of experience with Java and Android parallel programming. I should really again say modern Java, because we're not just Java 8 anymore, we're Java 11. And here's what we're going to do. We're going to be implementing a web crawler, which will go out and crawl starting at some root URI in the web or on your local file system to make things run faster, to make your network cellular plan bill not go through the roof. And it'll go out and it'll download files in a recursively structured directory hierarchy. So it'll start at the root and it'll crawl through the pages and it'll download the various pieces one by one. And so we're going to do it with a bunch of different ways of doing it. So we're going to use, initially we're going to use Java sequential streams. That's what your first assignment does. And then we're going to make that work with parallel streams. And then we're going to make it work with completable futures and reactive streams. And then we're also going to cross-cut that by having it access a web repository, which will probably run on your local computer, but it could be in a server somewhere in the cloud. And so we'll actually have some of the processing taking place in the server, some of the processing taking place on the client, and you'll get a chance to play around with a whole bunch of really interesting concurrency and parallelism models in Java. And the reason why we do it this way is because we've got this really cool Android GUI that will show you, literally show you what's happening as your program is running concurrently. So it's a lot of fun, and people seem to enjoy it. It'll also give you a chance to play around with all these Java functional programming features, lambda expressions, method references, functional interfaces, and so on and so forth. So that will be more or less what we're doing. I have this sort of like little caveat down here. Things could change. They're unlikely to change a whole lot. We'll probably stick with those things. The assessments are kind of interesting. So the way that this works, and I've used this technique in my classes for, gosh, pretty much 20 years. What happens is that when you submit your assignment, the course staff, typically me, will review it. Now, there's an important thing to note. You have to submit your assignment on time. So the way it's going to work, it's a two-phase process where you have an initial deadline where you have to submit your code for review, and then I review it, and I'll talk more about this in a second. But you have to make sure you submit it on time because I don't want to have to sit here, people straggling in and out. It gets very complicated for the review process. Also, take a look. This is where the frequently asked questions are, and it talks in detail about all this stuff. So your initial submission has to be a good faith effort. It has to compile. It has to be largely working. It doesn't have to be perfect, but it has to be an effort. You can't just throw gobbledygook in there and expect me to review it because that wastes everybody's time. So you have to keep up. And what will happen here is the following. So you'll submit it. I'll review it, give you feedback. This is why we're using GitHub and GitLab because I can push my comments to your code and nobody else can see it and so on. I will then make a frequently made mistakes video where I walk through everything that's could do better. Sometimes they're mistakes, sometimes they're just stylistic issues. Then you get a chance to revise your code. So I give you feedback, you revise your code, you then push your code back again, and then the TAs or graders or whomever will actually grade it. And the great part about this is the predominant amount of the grade is actually done using auto tests. So you should have a very good idea what your grade will be by the time you push your final submission. And so there shouldn't be a whole lot of surprises in that case. So that's kind of how the process works. It all is incumbent upon you to stay up with the course so that you don't fall behind. If you fall behind, it's tricky to catch up because all the assignments build on each other. So when assignment 2 comes out, they assume that assignment 1 worked. And if you don't have assignment 1 working, you lose points. So you have to make sure that you keep up with stuff. That's also described in the FAQ. Also important to attend class. Obviously, if you get COVID, please do not attend class. Please let me know. But otherwise, I expect people to be here in class. And the reason for that is mostly because, well, two things. First of all, we're back in class, darn it, and we should take advantage of that fact as long as we're here. And secondly, in my experience, people who don't show up to class then show up to office hours absolutely, completely confused, and it just wastes everybody's time. So please make sure you come to class. Also, everything is individual work. This is not a project course. I talked to the students last night over in the Commons about this. Some courses are project courses. The capstone design courses are team courses. The software projects course is a team course. This is an individual course, so quizzes and assignments need to be done individually. And that obviously relates to the honor code. As I mentioned before, the bulk of your grade is based on the results of automated unit tests. These tests are very, very helpful because they will give you incredibly detailed feedback on what you need to do. People sometimes get frustrated because sometimes the messages are a little bit less clear, but if you have questions, come to office hours. We're happy to help you out with that. And again, to reiterate what I said before, it's important that your latest assignment fixes problems that may have occurred with previous assignments. so that you keep up. By the time you're done, everything should work. The other thing why we do it this way is because it's really neat to be able to take the app that we have and then go through and run the different strategies for web crawling to literally see how they differ. I mean, you literally can watch them do things in different ways. So like the sequential one takes forever and it goes one at a time, and different parallel ones will do a whole bunch of processing and all the results show up and so on. So it's really cool to see them work. The relative weighting is typically 45% on the quizzes, 40% on the programming assignment, 10% on the final exam, and then 5% in participation. I'll talk more about that. The weighting could change if we don't have a final exam, then typically we add 5% to quizzes and 5% to programming assignments. So participation includes coming to class, being involved in class, asking questions, and coming to office hours, posting on Piazza and so on, and following directions. And following directions really means mostly not submitting your programming assignments late, because that ends up causing a lot of consternation, especially because there's so much manual review. I do so much manual review of everybody's assignments. It's important to have it done on time. And then there are other things which you can read about here on the webpage. If you don't show up to class, sometimes people say, I'm not going to show up for class. I'm just going to show up when the quiz is held. Well, now we do the quizzes virtually, so that kind of whole issue goes away. So you need to show up for class. So participate also. Don't just be a bump on a log. This is why you're Vanderbilt students, because you're something special. And we, as Peter Parker's uncle said in Spider-Man, with great power comes great responsibility. So your responsibility is to be involved. And that's the end of part 1.